Morning. Today's my lecture topic is jet engine parts and working principle. A jet engine is a complex machine designed to produce thrust. The inlet or air intake guides air smoothly into the engine. It minimizes turbulence and ensures uniform airflow. The fan draws in a large volume of air. Some air bypasses the engine core, providing additional thrust. The compressor is the first major component in the engine core. It consists of rotating blades and stationary stators. The compressor increases the pressure of the incoming air. High pressure air is essential for efficient combustion. The diffuser slows the air to prepare it for combustion. The combustion chamber is where fuel is injected and burned. It mixes fuel with compressed air in a controlled manner. Igniters produce sparks to ignite the fuel-air mixture that is happening in the combustion chamber. The resulting hot gases expand and generate energy. The turbine extracts energy from these hot gases. It has multiple stages of rotating and stationary blades. Turbine blades are made of heat-resistant materials. The extracted energy drives the compressor and fan. The remaining energy is used to generate thrust. The nozzle accelerates the exhaust gases to produce thrust. In afterburning engines, extra fuel is burned in the nozzle. The nozzle accelerates the exhaust gases to produce thrust. In afterburning engine, extra fuel is burned in the nozzle. This significantly increases thrust for supersonic flight. The bypass duct directs airflow around the engine core in turbofans. The gearbox in some engines optimizes fan and turbine speeds. The shaft connects the turbine to the compressor and fan. Bearings support the shaft and allow it to rotate smoothly. The oil system lubricates bearings and cools moving parts. The fuel system controls the flow of fuel into the combustion chamber. The air cooling system prevents overheating of engine components. Sensors monitor parameters like temperature, pressure, and vibration. So far we discussed the flight engine parts. Now we are moving to the working principle of a jet engine. A jet engine operates on the principle of Newton's third law. For every action there is an equal and opposite reaction. Air enters through the inlet and flows into the compressor. The compressor pressurizes the air, increasing its density. The pressurized air is mixed with the fuel in the combustion chamber. The fuel-air mixture is ignited, producing high temperature gases. These gases expand and accelerate through the turbine. The turbine exerts some energy to power the compressor and fan. The rest of the energy propels the gases out of the engine. The nozzle accelerates the exhaust gases, creating thrust. Thrust pushes the aircraft forward, overcoming drag. In turbofan engine, most thrust comes from bypassed air. This makes turbofans more fuel efficient than quieter. In turbojet engine, all air passes through the engine core. Turbojets are suitable for high speed and high altitude flight. In turboprop engine, a propeller is driven by the turbine. Turboprops are ideal for low speed, short haul flights. In ramjets and scramjet, there is no compressor or turbine. And scramjet means supersonic ramjet, that is called the scramjet. These engines rely on high speed airflow for compression. Jet engines are versatile and power most modern in aircraft. Continuous innovation improves their efficiency and environmental impact. These are the working principle of the turbojet engine. So the turbojet engine is the required one for the aircraft. Thank you.